Hello guys, welcome to my YouTube channel. In this video I'm going to be explaining one of the topics under physics, and that is electrostatics or electric charges. Under electrostatics I'm going to explain how electric charge can be transferred from one body to another, and I'm going to explain the types of charges that we have, and I'm going to show us the interrelationship between charges, the Coulomb's law expression. I'm going to show the mathematical expression of the interrelation, the force between charges, and how charges can be stored. There are two types of charges in general: the positive and the negative charge. In the nucleus of an atom, there are embedded protons in it, and which are positively charged. The nucleus of an atom is small compared to the size of the actual atom. It's of the order 10 to the minus 12 compared to the atom itself, which is about 10 to the minus 8. Electron revolves around the atom, nucleus of the atom, and the transfer of electrons is responsible for the charge carried by the atom, whether it's going to be neutral, whether it's going to be positively charged, whether it's going to be negatively charged. When the number of proton is equal to number of electron, number of proton, total number of positive charge, is equal to total number of electron, the atom is said to be neutral. This is neutral because the positive charge cancels out the negative charge. However, if the number of electron is less than the number of electron is less than the number of proton, the atom is positively charged. When the number of electron is greater than number of proton, the atom is negatively charged. So in this process, we observe that transfer of electron is actually responsible for the charge that an atom will carry, not the proton. It is the electron. Electron can be accepted or can be donated. If electron is accepted, the atom will have excess electron in its system, and thus it will be negatively charged. If it is donated, to be positively charged because there will be more proton in the system. So how can we transfer electron? By what method can an atom transfer electron, or by a body transfer electron? Electron can be transferred majorly by three methods: by contact, by friction, and by electrostatic induction. Contact and friction actually involves contacts, like touching each other, but electrostatic induction does not really involve physical touch. And we can store charge with the aid of electrophorus, by electrostatic induction, or with the use of capacitor. We also observe that I said there are two types of charges. There are two types. We have the positive charge and the negative charge. It is observed that like poles repel. That is, positive will repel each other, negative will repel each other. But unlike poles attract, positive, negative will attract each other. The magnitude of force of repulsion or attraction can be calculated using Coulomb's law. Coulomb's law. If you want to find the force, is used to calculate the magnitude of the force of attraction or repulsion of an electric charge. The force F is given by Q1 Q2 over R square times unit vector R, where F, force in Newton. The force is a vector quantity and it is measured in Newton. K electrostatic constant of the order 9.0 times 10 raised to the power 9 Newton meter square per Coulomb square. Q1 and Q2 charges of 1 and charge 1 and charge 2, and R equals to distance between Q1 and Q2. So I have explained how electric charge is generated or transferred. It is transferred by touch, by contact, by friction, by electrostatic induction. I want you to read further on that. And we have types of charges, and that is positive charge and negative charge. Positive charge will repel positive charge. Likewise, negative charge will repel negative charge. However, positive charge will attract negative charge, and negative charge will also attract positive charges. And thus, they came into conclusion that like poles repel one another, but unlike poles attract one another. So the force of repulsion and attraction can be calculated using Coulomb's law. Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional to the product of their charge and inversely proportional to the square of their distance. And the proportionality constant, which is the electrostatic constant, is given by 9.0 times 10 raised to the power 9 Newton meter square per Coulomb square. Another property of charge is that property of a charge. A charge is quantized. Property of quantization, that is, charge is an integral multiple of is in form of an integral multiple. This charge is equal to integral multiple n, that is 1, 2, 3 and so on, times the electric charge, electron here, for this. Charge is conserved. Sum of charge in a closed system will be equals to 0. It is conserved. So we are going to move on to the calculation aspect of electrostatic or electric charges, and I'm going to treat each case how questions can come up in the examination and what you should be expecting and how you should go about it.